In this problem of the function, we have to find the industrial cost for power cable. Okay, in this problem, a power plant sits next to a river, where the river is 8 feet wide. Okay, its wideness is 800 feet. To lay a new cable from the power plant to a location in a city which is 2 mile downstream, opposite side, on this side, opposite side, power plant here, in opposite side of power plant, 2 mile on the 2 miles, on the location of 2 miles, we have to downstream, opposite side. It costs $180 per feet across this river. Across this river, we can take it here or from this side, whatever. Across the river, according to the calculation, and 100 per feet from along the land. Along this land, it costs 100 feet, and from the across this water, it takes across the river, it takes the cost 180. We have to write a function of the cost in terms of distance x. This is x distance from a point. That's a point is q. Where should be x? Where should be the location we cross from the river? It should be here p, or between x is the value between p and q. Find the least expensive location of the q. The location of q should be least expensive. Okay, so now let's solve this problem. We have to write first is a function of x. Function means function of cost. The total cost will be the cost from this river, cost of the line cable from this river and on land. These both are different. 180 per foot and 100 per foot from the land. Okay, now let's solve. Okay, we the value of x when we want to find our total distance when we are want to find, we have to use the Pythagoras theorem here, because you know we have here this is a perpendicular line and this is a hypotenuse, and this one is a base you can take. Okay, so the total distance here, this distance hypotenuse, this distance from the river hypotenuse will be given by the formula Pythagoras theorem, means cost across river and cost across land. Okay, cost from the land, cost on the land, cost along land. Cost across river is given by 180 per foot, and the feet, total feet will be 800 square plus x square, value of base square and perpendicular square equal to hypotenuse square. This is cost across river, and the cost from the land. Total are 2 miles. We know well that 1 mile equal to 5,280 foot. In 1 mile, this is distance. So in 2 miles, the distance will be, this distance will be in 2 miles. Okay, 10,560 feet. So the total distance, the remaining distance, this will be remaining distance. The remaining distance will be 2 miles minus x. 2 miles equal to these feet minus x. Okay, so the cost from across the land will be, the remaining will be the cost from the land. Okay, so adding these both, the cx will be equal to adding these both, adding the cost from the river plus cost from the land. Cost from the river is this This is the cost from the river, square of this. Okay, square of 800 feet plus square of the x, whatever the question means we will estimate according to the table whatever the value of x we get for the least expensive. For the least expensive point, this q we will get after substituting values and making a table, generating a table. Okay, from this is a function for the cost. We have to generate a table. From the table we have estimated what should be the value of x for a minimum cost. For a least expensive location we have to find the value of x. We have to generate a table. Okay, after generating table we can decide what should be the value of x.